Hello, welcome back to Advent of Code 2023 Enclosure. This is day 8 and it had to happen sooner or later, but I wrote, I thought I started recording, but I didn't record, and now day 8 is solved, which you can see here. They're both complete. So what I'm going to do is I'm just quickly going to go over what the problem was and how I solved it. So the problem effectively was that we are lost in a desert, we have pieces of a map, and the way the map is encoded is it always tells you if you're at this position and you turn left, you end up at this position. If you turn right, you end up at this position. And then at the top, there are instructions on how you should navigate through the map. So this means turn right first and then turn left. And if you haven't, and the point is to reach Z. So you start at AAA and you need to end at Z. If after these instructions you're not where you should, you're not at Z yet, then you just repeat the instructions. So they're like effectively loop. And part 1 was basically just like counting how many steps it took you to navigate through the map until you reach Z. So the way I have gone about that was I parsed the input into the instructions and then maps. Well, I probably could have called it like steps or something like that. And what this effectively is this is a big map where we have a key of where we are right now, and then a key of, for example, left would go to BBB, and right would go to CCC, and then an entry for BBB, etc., CCC, and all of them. So effectively, every single line of the input turned into one entry in the overall map, and then all we need to do is like traverse this map with our steps, right? So where you are right now, and then if you turn left and if you turn right. And that's what I did. So once I had it passed into the map, I just looped over the instructions being cycle instructions. So cycle takes a sequence and repeats that indefinitely, or infinitely. Indefinitely, I think. I'm not sure. As a lazy sequence. We start with count 0 in our starting position of AAA. And then if we hit Z, we just return the count. Otherwise, we update the count by 1. We grab the rest of the instructions, right? So the rest drops the first item. And then we update the position by looking at the maps, getting the current position first, and then either turning left or turning right. And that was super fast. And yeah, that just worked. So part 2 was a little bit trickier. So effectively what we had to do, it's talking about like ghosts and stuff, I'm not sure about that. But effectively what we had to do is we had to traverse the map in parallel multiple times. So it actually said you start at every entry that ends in an A. So here that would be 2 entries where you're starting at. And you traverse them at the same time until they're both at positions that end in a Z. So they have this example here. So you start at 1A and 2A. You choose left for both of them, so you end up at 1B and 2B. So this one and that one. Then you choose right at them, and that one leads you here to 1Z. But that doesn't count yet because both of them need to be 1Z, because if you turn right on that one, you end up in 2C. So you keep going, then like one of them is Z again, you keep going, and then at some point, both of them hit 1Z and 2Z. So both of them end now in a Z, and you take the count of these. So I first tried brute forcing it and just running over it, but and like basically repeating the count steps in parallel and updating my condition to say all of my positions end in a Z, but that was like took way too long. So instead I went for a lowest common multiplier math approach. So I effectively just count the steps now until we hit one of them being, sorry, let me rephrase. So I took all of the keys from the maps and filtered all of the ones that start with an A, right? So that gives me a list of all of our starting positions. And then what I did is I counted the steps for each of those before we hit the first element ending in Z. That gives you then a list of numbers, and then you find the lowest common multiplier between them. There is a little library called FastMath that does that for you quite quickly. And that solved the problem as well. And it was like a huge number. So what is that? That is like millions. Wait, is this right? So hundreds, thousands, millions, billions. Yeah, so 14.6 trillion. Yeah. So sorry I didn't record it. But yeah, I didn't want to pretend like I'm solving it when I did. So yeah. So that's it for day 8. Thank you very much. Hope to see you day 9. Bye bye.